Well, welcome to Lesson 5. We're still in Section 6.2, Trigonometric Functions of Angles. So we're going to use the coordinate system today. Notice I threw a right triangle on here, and notice the central angle is theta. That's the angle in question. And notice that the adjacent side corresponds to the x value, and the opposite side corresponds to the y value. And this is something that I'm going to hammer home over and over and over again. The idea that the cosine of theta corresponds to the x-axis and the sine of theta corresponds to the y-axis is one you need to get used to. When you think of x, think of cosine. When you think of y, think of sine. X adjacent, y opposite. So here's our first problem. If theta is an angle in standard position on a rectangular coordinate system, well, all of our angles are in standard position on a rectangular coordinate system. And if a random point, 5, 12, is on the terminal side of theta. Now remember, there's an infinite number of points on the terminal side of every angle. And any one of those points will be good enough for us. If we have any point on the terminal side, that's all we need. So 5, 12 happens to be the one we grabbed. That's enough information to find the values of the 6 trigonometric functions of theta. Well, 5, 12 is a point in quadrant 1. And so we grab the point out there, and then we make a right triangle out of it. We drop straight down to the x-axis. Always go back to the x-axis. Never go to the y-axis on these. And you notice that the x value is 5 and the y value is 12. That's what the point 5, 12 means. You're out 5 on the x and you're up 12 on the y. And if we do Pythagorean theorem, a squared plus b squared equals c squared, we get the hypotenuse to be 13. And that's enough information to find the value of the 6 trigonometric functions. And so your sine is 12/13 opposite over hypotenuse. Your cosine is 5/13 adjacent over hypotenuse. And the tangent is 12/5. And that's y over x. And remember, tangent is slope, because tangent is opposite over adjacent, y over x. And your slope is also the change in y over the change in x. So tangent and slope are the same thing. And then you see you have your 3 reciprocals. Let's do another one. If the angle is in standard position on a rectangular coordinate system, yeah, I know. And if the random point that we picked off that terminal side happens to be -4, 3, find the value of the 6 trigonometric functions. Any point on the terminal side will be good enough. So let's go ahead and draw this over in quadrant number 2. And if we do that, we see we have -4, 3 there. And we're left 4 on the x, and we're up 3 on the y. And so you see your 3 is y, your -4 there on the x. We'll do Pythagorean theorem. And the Pythagorean theorem tells us that the hypotenuse is going to be 5. And as soon as we label that, we can get the 6 trigonometric functions. Now remember, hypotenuse is always positive. Never have a negative hypotenuse. X or y can be negative, but the hypotenuse is always positive. And our sine is positive 3/5, and the cosecant then would be in positive 5/3. Yeah, we're in quadrant 2. Sine's positive in quadrant 2. Cosine is -4/5. Secant is a -5/4. Yeah, we're in quadrant 2. Cosine is negative in quadrant 2. And tangent is a -3/4, and the cotangent is -4/3. Yeah, we're in quadrant 2, and tangent is negative in quadrant 2. All right, so let's continue this idea with a slightly different type of problem. Find the values of the 6 trigonometric functions of theta if theta is in standard position, and the terminal side of theta is in the specified quadrant and satisfies the given condition. So in this case, the terminal side is in quadrant 3, and it's on the line 4x minus 3y equals 0. Well, we either need a point on the terminal side, or we need one of the 6 trigonometric functions in order to get it. And so all we know is it's in quadrant 3, which means sine and cosine will both be negative and tangent will be positive. It's on the line 4x minus 3y equals 0. So what can we extract out of that 4x minus 3y equals 0? Well, we can solve that equation for y. That'll put it into slope-intercept form. And if we have that, we have the slope. If we have the slope, we have the tangent. And if we have the tangent, we are off to the races. So I've drawn it down there in quadrant 3. I want to get that 4x minus 3y into y equal mx plus b form, slope-intercept form, because slope is the change in y over the change in x. It's sine over cosine. It's tangent. solve for y, grab your slope, you have your tangent. And if we do this, 4x minus 3y equals 0, subtract the 4x, divided by the negative 3, and notice we have a positive slope. Yeah, remember this in algebra? Lines going up to the right, or I guess in this case down to the left, have a positive slope. That's another reason why tangent's positive in quadrants 1 and 3, because those are lines that have positive slopes. Tangent's negative in quadrants 2 and 4, because those are lines that have negative slopes. So our slope is 4/3, which means our tangent is 4/3, and that's all we need. Now we can build our triangle up. And so there's the point, -3, -4, and we're -3 on the x, and we're -4 on the y. I didn't seem to draw a triangle that was in proper formation there. That's okay. It's not right quite scale, but we'll have to live with it. And 3 squared plus 4 squared equals 5 squared. So our hypotenuse is 5, and that's enough information to do it. Notice that our sine and cosine are both negative, and your tangent is positive. Sine is y over hypotenuse, cosine is x over hypotenuse, and your tangent is y over x. So -4 over -3 reduces down to 4/3, but we already knew that was going to be 4/3 because we figured that out from the slope. That's not so exciting. Now we're going to do another one very similar to this one, but there's a little bit of a twist to it. This time the angle is in the terminal side of the angle is in quadrant 2, and it's parallel to the line 3x plus y minus 7 equals 0. That's not a whole lot different than what we've already done. The only difference is the line that we give you isn't actually on the terminal side of the angle, but it's parallel to it. Our terminal side is still going to come out of the origin. What we need to extract out of this is slope, because if it's parallel to it, then our terminal side will have the same slope as this line. If it has a slope, well then of course we have your tangent. So I drew it in quadrant 2, and I've written this again. Y equal mx plus b, slope equals change in y over change in x, sine over cosine, and that is equal to tangent. So the line is actually y equal -3x plus 7. So this line actually intersects the y-axis all the way up there at 7. I don't care where the line's at. All I care about is the slope is -3. Now notice I wrote that as -3 over 1 because we really kind of like to have fractions with these. So I wrote as -3 over 1. Be careful on that. Cover up the negative. You don't want that negative to influence you on the next move. Tangent is y over x. Keep saying that over and over again. Tangent is y over x. We'll worry about the negative later. So as it turns out, it wasn't -3 over 1. It was 3 over -1 because the y is the 3 and the x is the 1. And because we're in quadrant 2, the negative goes on the x. And so the mistake students make here is they force the negative on the 3. They either make it -3 on the y, which makes no sense. You can't go up -3. Or they actually do x over y to force the negative to be on the x. So don't worry about the negative. Always place these as y over x and then worry about the negative later. So in this case, we ended up with 3 on the y, -1 on the x. Pythagorean theorem, we end up with a hypotenuse of square root of 10. And that's enough information to come up with the 6 trigonometric functions. And I don't bother rationalizing those denominators. I think we're fine the way it is. I know sometimes people get a little upset about that, but I think we can live with it. Let's move on. All right, so here I've given you just a plain old Cartesian plane with the quadrants labeled 1, 2, 3, and 4. And now I'm going to put sine, cosine, and tangent into each one of these, and we're going to put little pluses and minuses next to them so we can figure out where they're positive and where they're negative. Now remember, sine and y go together. Cosine and x go together. If you know where y is positive and negative, you know where sine is positive and negative. If you know where x is positive and negative, you know where cosine is positive and negative. And so in quadrant 1, sine and cosine are both positive, therefore the tangent is positive. Remember, tangent is sine over cosine. In quadrant 2, sine is positive, but cosine is negative. That's because the x is negative. Tangent is sine divided by cosine. Positive divided by negative is negative. In quadrant 3, sine and cosine are both negative. Therefore, tangent is positive. And in quadrant 4, the sine is negative because y is negative. The cosine is positive because x is positive. And the tangent is negative because negative divided by a positive is a negative. And then we have a little trick. All students take calculus, ASTC. I see this all the time. All of them are positive. Notice the capital letters there. All of them are positive. Sine is positive. Tangent is positive. And the C, cosine, is positive. All students take calculus is a little trick to remember. They're all positive in quadrant 1. Only the sine is positive in quadrant 2. Only the tangent is positive in quadrant 3. And only the cosine is positive in quadrant 4. So now we play a little game called Find the Quadrant. Find the quadrant containing theta if the given conditions are true. Now, where is tangent negative and cosine is positive? Well, tangent's negative in quadrants 2 and 4, and cosine is positive in quadrants 1 and 4. Therefore, theta has to be in quadrant 4. Let's do the next one. Secant is less than 0. Secant is the reciprocal of cosine, so that means cosine is negative. That's 2 and 3, quadrants 2 and 3. Tangent is negative in quadrants 2 and 4, so they must be in quadrant 2. Let's do the next one. Cosecant is greater than 0. Cosecant is the reciprocal of sine, so that means we're in quadrants 1 and 2. Cotangent is greater than 0. Well, cotangent is reciprocal of tangent, and that's positive in quadrants 1 and 3, so it has to be quadrant 1. All right. Cosine is less than 0 in quadrants 2 and 3. Cosecant is less than 0. Well, that's the reciprocal of sine. That happens in 3 and 4. So this must be in quadrant 3. And my last one here, E, says the cosine is less than 0. Well, cosine less than 0, that happens in quadrants 2 and 3. And secant is greater than 0. Well, secant is the reciprocal of cosine. That happens in quadrants 1 and 4. And so this doesn't work. There is no theta that can be in quadrants 2 and 3 or quadrant 1 and 4. So there's actually, this theta does not exist. So that's a little trick we play. You just have to think about which two quadrants the first one is in, what two quadrants the second one's in, and wherever they agree, there you are. And I have one here that didn't work. All right, so this one uses the fundamental identities to find the values of the trigonometric functions for the given conditions. Now there's two ways to do these. We can use the fundamental identities, 1 plus tangent squared equals secant squared. Or we can just build the triangle up in the correct quadrant. And that's what I'm going to choose to do. It says tangent theta is 12/5 and the cosine is less than 0. Well, the first thing you better figure out is what quadrant are we in. And let's see now. It says tangent is positive. Well, that happens in quadrants 1 and 3. And cosine is negative. That happens in quadrants 2 and 3. So this must mean we're in quadrant 3. So I build my triangle up there. Now remember, tangent is y over x. So that's 12 on the y, 5 on the x. And you put negatives with both of them. So that point out there that we have is negative 5, negative 12. And then we do Pythagorean theorem and we come up with a hypotenuse, which is 13. And this looks very familiar to what we did earlier. That's enough information to find the 6 trigonometric functions. Your sine is y over hypotenuse, your cosine is x over hypotenuse, and your tangent is y over x. And then you have your reciprocals. We're in quadrant 3, so tangent is positive, and sine and cosine are both negative. Let's do another one. All right, we're going to wrap up with this one. Our secant is negative 4, and our cosecant is greater than 0. Now, secant is the reciprocal of cosine. That's negative in quadrants 2 and 3. Cosecant is the reciprocal of sine. It's positive in quadrants 1 and 2. So my guess is, yes, quadrant 2 is where we're at. All right, so we're going to build our triangle up in quadrant 2. And when we do that, the secant is negative 4 over 1. That means the cosine is negative 1 over 4. That's adjacent over hypotenuse, or rather x over hypotenuse. So I'm going to put the 1 on the x and the 4 on the hypotenuse. The hypotenuse is never negative, so the negative had to go with the 1, and it makes sense. We're going left there. We do Pythagorean theorem when we come up with b to be in the square root of 15. And you know what? This is looking a lot like what we've done earlier. And if you have all 3 sides of the triangle and you got them properly labeled, you know what quadrant you're in, you can get your 6 trigonometric functions rather quickly. Look at sine's positive. Yeah, we're in quadrant 2. Cosine's negative. We're in quadrant 2. Tangent's negative. Yeah, sine divided by cosine would give this to us because we have a positive divided by negative. In quadrant 2, the tangent's negative. All right. Well, that wraps up lesson 5. Please get to work on the homework for lesson 5.